All right, this is lesson 58, Tangents and Circles, part 1. We've already discussed tangents in a former lesson, so this will sound like review, but we're going to expand on this knowledge today. So let's start with the definition. What is a tangent line? It's a line that lies in the same plane as a circle, so that's your first blank, and intersects the circle at exactly one point. So if you'll notice down here at these two diagrams, we have a tangent that touches the circle at exactly one point. That's called the point of tangency. So in this case, point G is where tangent EF intersects the circle. And over here, point U is the point of tangency that this tangent touches the circle. So let's go over these theorems real quick. Over here we have theorem 58-1 that says if a line is tangent to a circle, so right here, then the line is perpendicular. What does perpendicular mean?
Right angle.
Yep, it intersects at a right angle to a radius drawn to the point of tangency. So notice how we have a radius here and it's touching or intersecting the tangent line. Well, when that happens, we can safely assume because of this theorem that this is a right angle. Draw that in for me. And as it says right here, line EF is perpendicular to line DG. Now, theorem 58-2 is the converse of 58-1. So notice it says if a line in the plane of a circle is perpendicular, see the clue right here with that right angle, to a radius at its endpoint on the circle, then the line is tangent to the circle. So this is vice versa. If they give you this clue and they tell you that the radius is perpendicular to this line, you can safely assume that it's tangent to circle V. All right? So both of these are opposites of each other. Last theorem, 58-3, says if two tangent segments are drawn to a circle from the same exterior point, look over here. Do you see this exterior point Q? Do you see how both of these tangents are drawn from the same point? When that happens, you know based off of this theorem that they are congruent. So segment MQ is congruent to segment NQ. So take your pen and draw a tick mark on both of those on your diagram to show that both of those are congruent to each other because they're coming from the same exterior point. Okay, time to do some sketching. When you're asked to sketch a diagram, you want to first read through all of the clues carefully and then go back and make sure you've drawn each and everything that they've asked you to draw. So we'll start with reading it. It says line N is tangent to circle C at point P. Line M, a different line, passes through C. Lines N and M intersect at point Q. So the directions say to sketch circle C and lines N and M, mark C, P, and Q on your sketch. Okay, so I'm going to walk through this with you. As best as you can, draw a circle.
Will you ever make us do this on a test?
I might make you locate and identify where they are and what the parts are.
But not like draw it out. Like you'll give us the picture and you'll just say.
We'll see. Okay, so start with the center. What is this circle called?
Sphere.
No, like what is it named rather? What do the circle what? C. So because it's called circle C, I know I have to put C at the center of the circle because that's how we name them. Remember that was on your last test? Okay. It says line N is tangent to circle C. So as best as you can, draw a line that touches the circle at one point only. So like that. Okay, what is this line called or named? N. So N. And it touches circle C at what point? P. Now, there's another line, line M, and it goes through C and it intersects line N. What's this line called? M. And the point at where it touches line N is called what? What's that point? Q. Okay, let me see if I follow directions. It said sketch circle C. Okay, got that. Lines N and M, here and here. Yep. Mark C, P, and Q. So C, P, and Q. All right. I followed all the directions. This would be the answer. Now, this is an extended question over here. It says, if the measure of angle CQP is 36, so let me find that. It says CQP. Okay, let me get a different color out. They're telling me this angle right here is 36 degrees. Mark that on your diagram. The question asks me to determine the measure of angle PCQ. So hold on, let me get my pen out. They want this angle right here. PCQ. PCQ. They want this angle right here.
Wouldn't P be 90?
Very good. Did you hear what Harper said? She said that this right here is 90 degrees. We know that from theorem 58-1. We needed to know that in order to solve this.
So it's 54 degrees?
How did you get that?
You add 90 plus 36 and then subtract that from 180.
Perfect. Good work, guys. You add the 90 plus the 36 degrees and take that out of 180 because we know that's triangle sum theorem. And we get measure of angle PCQ. Ooh. Measure of angle PCQ equal to 54 degrees. Good work. Okay, bottom left. In this figure, segment JK, so where is it? Right here. And JM, right here, are tangent to circle L. So they're telling us that to be true. The question says, determine the perimeter of quadrilateral JKLM. What type of quadrilateral is JKLM? Why don't you give this one a try? Okay, what'd y'all get?
Yep, 50 inches. That's what I got.
Yeah.
Okay, how do you get that? Harper, walk me through that one.
KJ is 17 inches, so that means MJ is also 17 inches.
Good.
And then LM is 8 inches, so that means LK is 8 inches. And we add more
Very good. So perimeter is equal to 50 inches. Am I finished?
No.
Why not?
Because you need to know what type.
Yes, thank you. Y'all are getting into such a good habit of making sure to answer all the parts of the question. Okay, what type of quadrilateral is it?
I did not know.
I didn't know.
Square.
Definitely not a square, Thomas. Take that back.
Rectangle.
Triangle.
We know that squares have congruent sides. That cannot be. Guys, this is a kite.
A what?
I don't even remember learning.
Close enough.
A kite.
We haven't talked about that since we were like
See,
in 5th
look.
grade.
I know.
This is back in like lesson 5.
When consecutive sides, yeah, lesson 5. And what did I tell you when we started this class?
Everything's gonna come back.
Yes.
And if you forget it, you're gonna fail.
All right.
Sorry.
These two consecutive sides are congruent, and these two consecutive sides are congruent.
Doesn't even look like a kite.
That makes it looks like a
Looks like a
kite.
cone.
Look, here, does this help?
It does look like
The-
a cone.
It looks like a cone.
Does
But-
it?
There.
Looks like
Cone
an
with ice cream on top.
Yes.
It's a cone.
Oh my goodness. Okay, bottom right.
Oh, no.
I agree, it's rigged. I'm gonna sue.
Gonna sue. All right. If the measure of angle BEA is 45 degrees, we need to label that in our diagram. Show that line BD is tangent to circle C. So we're going backwards. We need to prove that BD is a tangent line. They're not giving that to us as information. We need to show that. So first things first, see how it's BEA is right here. So we're going to label that as 45 degrees. Okay, take a look at that and tell me what you know.
BD connects at point E.
BD connects at point E, that's true. This line right here touches the circle at one point. But there's something else we need to show.
There's a right angle.
Tell me more. You're very warm. You're on the right track.
These two sides are congruent.
Okay, yes, Kellen's pointing out that there's an isosceles triangle here. What do we know about the base angles?
They're the same.
They are. What do they measure?
90 degrees.
30.
So this is 90, and both of these have to share the rest of the 180.
45.
Yes. So this right here is 45 degrees, and then like Kellen said, if we can show that this is 90, we will have proven theorem. What are the numbers? Which theorem says if we start off with the right angle, we can prove the line is tangent, as opposed to being told that the line is tangent and assuming the perpendicular 90-degree angle?
581.
Not 581. 581 says that they're telling you it's tangent.
582.
Yes. Theorem 58-2. And we can write in here that angle BEC equals 90 degrees. Before I move on, does that make sense?
Yes.
Okay, good. Because I can explain it if you need me to.
You just added the 45 and the 45.
Correct. All right. Moving on to lesson 59, finding surface area and volume of prisms.
I hate surface area.
I know, but you guys have been doing this for a while,
Yeah,
so
but
that's
I never
good.
understood it.
Well, hopefully you'll
Always
understand
got
it
wrong on
today.
the end of the test, especially the
It was like
Saxon.
30 years ago.
I will help you.
Always that, yeah. Problem 20 was always surface area. And I always get that wrong.
45.
Yeah.
It is always the last question in Saxon. Okay,
Yeah, even in
Surface
homework, it's the
area.
last question.
it's the total area of all its faces and curved faces. Lateral area, however, is the sum of the areas of the lateral faces of a prism or pyramid, or the surface area minus the bases for a cone or cylinder. I'll explain that in greater length here in a minute. Volume is the number of unit cubes of a given size that will exactly fill the interior of a solid. So all the space inside of. Okay, let me zoom in right here on this figure. These pentagons are the bases. Okay, these right here are the lateral faces. So when we say lateral area, we want the area of this figure minus these bases. So not including the top and bottom bases, the two parallel figures. Okay. Now, when they want total surface area, they want all of it. But when they're asking for lateral, they just want the sides. Okay, and then obviously the volume is filling up the inside, like a can of Coke or a cereal box. Okay, these formulas will go into your formulas chart. The first one is lateral area formula, which equals the perimeter of the base times the height. And we'll work a few of these here in a minute, so it'll make more sense. Surface area formula, it takes the lateral area that we just found and we add that to twice the area of the base. Keep in mind, big B does not stand for base. Little b, lowercase b stands for base. Uppercase B stands for area of the base. So don't get those confused.
Why wouldn't it just be AB?
Why wouldn't it just be AB? There's too many letters because A goes in the front. No, because then
So
A
big B is
normally
area?
stands for altitude. See, they all have assigned values or given.
Okay, never mind.
Okay. What'd you say, Thomas?
So big B is area.
Big B is area of the base. Little b is just base. You know how for area of a triangle, it's base times height? That's why it's little b, little h. But big B is area of the base. Logan's shaking his head. Okay. Volume formula. This one's not new to you. It's area of the base, right? Big B times the height. Okay. Let's put some of these into practice. This one right here asks us to find the lateral area of the hexagonal prism. What is the formula for lateral area?
Perimeter times height.
Yes. So, look over here. Notice how this is a hexagon. That's why it's called a hexagonal prism. We want to find the perimeter. So, perimeter, and write this down, please. Perimeter equals 6 sides times 12 feet per side. What is that?
72.
Thank you.
That's the perimeter?
Uh-huh. Because 12 plus 12 plus 12 plus 12 plus 12 plus 12.
But you don't need to put that as 18.
What is 18?
Like.
Oh, that's going to come here in a minute.
Oh, okay.
So we just found this, right, Kellen? We found the perimeter. And then you're telling me 18. Well, 18 is the height.
Oh.
So right now we're going to do lateral equals the perimeter, which we just found to be 72, times the height of 18. I found the 18 right here. This is the height of the figure, the solid. We punch that in, and what do we get?
So it's 1296
1296 what?
feet squared.
Yes, because it's area, so we label it in squared units. Okay, let's move over here where they're asking for.
For that one, could I just do 12 times 18 times 6? Because, like, the perimeter for each of them.
For this particular one, yes, but just be careful because this will always change, right? It might be a pentagon, so 5, right? Or a quadrilateral, 4, so.
Because I got the same answer.
Yeah. So yes, you can. Just be careful with the number of sides because it changes every time.
So you just multiply all the numbers they give you and
For
subtract the
lateral,
side. Yeah.
depending on the figure they give you, right? That's why I don't really want to teach it like that, because it just depends on the number of sides. That's the part that's ever changing. Okay. This one over here asks us to find the surface area of the pentagonal prism. See what I mean? They just changed it. It was a hexagon, now it's a pentagon. This is a prism, it might be a pyramid next, see? Okay. What is the formula?
Base times height.
Lateral area plus 2 area of the base. And then
Perfect.
add it together.
So that's the formula for surface area. Lateral area plus twice the area of the base. Okay, so lateral area, y'all told me earlier, was the perimeter times the height. So we have to start with the perimeter. How are we going to find the perimeter of that base?
You're going to do 5 times 5.
Very good. 5 sides times 5 inches per side. That gives me
25.
25. Now, lateral tells us that we need to take the perimeter that we just found and multiply it times the height. What's the height of the solid? Very good. What does that give me?
175.
175. We'll save that for later. We got to keep going. We found this, but now we have to find the area of the base. Correct. So, area of the base. Notice that these are triangles, and we have 1, 2, 3, 4, 5 of them. So let's start by finding the area of one triangle.
And then just multiply it by 5.
Yes, and then just multiply it by 5. So help me find the area of one
Well,
triangle.
the base is 5 on the triangle, and so the height would be 3.44. So you would do 5 times 3.44.
Which is 17.2. Divide that by 2, which is 8.6.
8.6. Now that's just one of those.
And times it by 5, then it's 43.
43, you said?
Yes.
Okay. Now we're ready to plug it into surface area.
So do you just add those together? 175 and 40.
175 plus 2, right? 2 of these. That's what the formula says.
The answer
61
261 what?
inches squared.
Very good. Okay. Not hard, right? Just follow the formula carefully. Keyword carefully.
Lots of math errors could be made.
I agree. Did you hear what Kellen said? If you're not careful, there's a lot of room for silly mistakes. So though you know the formula, though you know how to apply the formula, you got to be careful. Okay, volume. Find the volume of the rectangular prism and the oblique prism.
Base times height. Whole area of base.
Yes, volume equals area of the base times the height. Now, this is a trapezoid. Do you remember the formula for area of a trapezoid?
Isn't like base
Base
times
1.
height divided by 2?
Base 1 plus base 2.
Yes, base 1
And then
plus
divided by
base 2 times the height, all divided by
2.
2. See up there? 8 plus 12, so add the bases, times the height. The height is 5 of the trapezoid. Be careful, not the height of the entire solid, just the height of the base. And then all of that divided by 2. Tell me what you get.
Yeah,
50. Now we're ready to find the volume, which is what they asked for, by taking the area of the base, which is 50, times the height of the solid, which is 9. So the volume equals
450
450 what?
feet squared.
Ah.
Cubed.
Feet cubed, cubic feet, because we're finding volume. Volume is measured in cubic units. Okay, why don't you give this one a shot? Find the volume of this oblique prism. Same formula. Find the area of the base and multiply it times the height.
Would the height be 2 inches?
That's of that triangle.
Yeah.
The height of the triangle, correct, 2 inches. The height of the solid is 8 inches.
So you multiply those?
Well, what's the formula for volume?
Base times height.
Not base times height. Area of the base times the height. So
You
find the
multiply those
area
by
of the
5.
triangle
Oh.
and then multiply that answer times the height of the solid.
And you add them together.
Add what together?
The areas of the heights.
For volume, you just want to find the area of the base, so the area of this triangle, and then you want to take that answer and multiply it times the height
I
of
found
the
the
solid.
area of the whole thing though.
No, you
Okay.
just want the area of the base.
Okay. And then the height would be 8.
Yeah, so the height of this triangle is 2, but the height of this solid is 8.
8 times 6. 48. Somehow I still got 48 with what I did, but I don't know what
got 48 too.
But I did something completely different.
Oh, okay.
All right, Thomas, work me through this one. Walk me through this one.
So I don't know if I did it right, but I just did 11 times 8, and I got 88.
Wait, pause. Why'd you do 11 times 8?
So I was figuring out the area of the base for the rectangle.
Okay, so the way you know if it's a base is if there's 2 of them and they're parallel to each other. So look up here. See this and this?
Mm-hmm.
These are the bases. Because there's 2 of them and they're parallel to each other. Because this is a triangular prism. And so the reason it's called triangular is because the bases are triangles.
So that'd just be 11 times 6 then?
You actually don't even use the 11. The 11's there to trick you. Because they want you to think that 11's the height, but it's not. 8 is the height.
So it's 6 times 8?
6, this triangle right here, zoom in right here. I want you to find the area of this triangle.
I did 6 times 2 and then divided that by 2.
Uh-huh,
And
yeah.
I got 6.
Yes. So let me write that out. Big B, which is area of the base, meaning the triangle, is base, which is 6, times 2, which is the height, divide by 2, which is nice because look, I can cancel those 2's. So the area of the base is 6. Now, volume equals area of the base, which we just found is 6, times the height of the solid, which is 8.
So it's 48
Yes, 48 what?
inches cubed.
Very good. Now, like I was saying earlier, you want to be careful. They gave you this 11, but the 11 is extra information. They're trying to throw you off and thinking that that's the height. But the height is always perpendicular. So the 8 inches is how tall this oblique prism is. You wouldn't use this slanted, right there, that slanted lateral edge. Okay, I would like you to try this one on your own.
No.
Rick has a gift he needs to wrap. He has 15 square feet of wrapping paper. Does Rick have enough wrapping paper to cover the gift shown in the diagram?
That's so
Surface area.
different.
Yeah, it's an application problem. They're the best. You don't agree?
I don't agree. Okay. So wait, the lateral, it's the perimeter of the whole shape or just one side of the shape?
Lateral is only, like, if you look at my cup, this is the lateral. It doesn't include the circular bases.
So like if I'm looking at this shape, it would just be like of like that shape.
It would just be the sides. And you don't,
Oh, so
when
like
you
this
wrap a
shape.
present, you don't just wrap the sides, right? You wrap the entire gift.
Mm.
So we don't want lateral.
Kellen, I think we learned for this in like 6th grade too. I remember Miss Huggins teaching us it.
Wait, but no, you need to do the surface area, but the lateral is in the surface area.
Oh, you're right. The
Yeah.
lateral
Yeah.
is in the surface
Yeah, I
area.
was like,
I'm
wait,
sorry.
what?
I didn't mean to confuse you. I thought you were asking me because you were solving for lateral.
Oh no,
Okay,
I was
keep
just
going.
using that to solve.
Tell me your question.
So I would do 3 plus 1 plus 3 plus 1.
No, because the base is a 2x3. The 1 is how tall the gift is. Right? So if you're finding perimeter of the base, there's 2, 3, 2, 3. There's a
Oh.
rectangle at the bottom.
Okay, I got it.
Okay.
2 plus 10. So it's 10 for the lateral.
Mm-hmm.
10 plus.
Here in online science.
Did you get 16?
No.
10 plus.
You were right about the 10.
Yeah, so then I.
That's
need-
your
Just
little.
what's the area of the top and bottom together?
What?
Okay, after you did the lateral of 10.
You gotta do the 2 base. 'Cause
Yeah.
Then you have to add those together.
So what's the area of the base? The
So-
2x3.
2 by 3. Oh, 6.
Yes.
And then you.
And then now you can
plug.
plug it into your formula. Yes.
Oh.
So you said 2 of those. 2 6s.
So it's 12. So it's 22.
Yes. So then you have to answer the question, though. The question didn't ask how much paper does he need. It asked, does he have enough?
No. He doesn't because he has 15.
All right, Logan, will you walk us through this one?
It'd be 6. So it's like 3 times 2.
So that's the area of the base.
Yes.
Big B equals 6.
6.
Okay.
And then you do that times 2.
All right.
That'd be 12. And then you do 12.
Like these.
They do 2. Oh, that's the height. Did you use 12 times 2?
No. So far, you found this. So what is the formula of surface area?
Lateral area plus 2 area of the base.
Hold on. Lateral plus twice the area of the base. So you just found this for me. Actually, you found this whole thing. Now I need you to find the lateral. Which is what? Perimeter times height?
Yeah.
So find the perimeter for me of the 2x3 bottom rectangle.
10,
10 times the height,
which is 1.
1.
Then it's add 'em.
Yes, you just add them. Now, I was asking Kellen just a minute ago, is that my answer? 22 square feet.
No, because it asks, does it have enough wrapping paper?
So what's my actual answer?
No.
No, that's my answer. He needs 22 square feet. He only has 15 square feet. So no, he does not have enough.
Okay, so like,
Okay.
can we practice the triangles now?
Yes.